The second one is building design. We show one tower, and we will actually open this file to show you and infrastructure projects. So getting into the detail of this again, what I just showed, I want to give a little bit more information on how we set up the file and how we create our panels and how automation works through that. I'm sure those who are starting new or has been using it would appreciate our way of doing this. Maybe you can have comments for us as well. As mentioned, we bring our original models from Rhino. We extracted the plates, though we use Excel file actually to create our levels in XGenerative or in CATIA, but we also have a surface model. We use XGenerative tool to create our panel surfaces individually, and we were also able to do analysis in XGen to see typical, non-typical conditions. And then we are using building engineering tool to create our different type of panels. As you see, there are many different type of conditions that happens because of the folding of the surfaces and straight and slanted areas. Once we create and identify different type of panels we need, we work with the using our surfaces or divide the surfaces and the panels. We instantiate them in assembly design, and from that we create our detailed panels coming here. So getting a little bit more in detail here, for the panels, we are able to create lists of items to categorize our information, right? We want to split the surfaces to left, typical, and right conditions on the surfaces as basis to start. Those split into further actually as spandrel glazing versus glazing, and from that we also define non-typical conditions by looking at what kind of geometries we have created or results from the geometry of the building, and those are triangle and some multi-corner panels. And then lastly, we have corner mullions, which are changing angles and changes profiles because inward or outward conditions. So this was also automatically done, which I will actually showcase here. In this case, in the previous video, I show how our nib condition changes as per the surface angle, whereas our mullions stay perpendicular the whole time. So that was a challenging design feature, as simple as it sounds, that we had to test. I have a quick video here showing how we apply our corner mullion. So we created this left and right side of the corner, and using our sketch here, and it's responding to design changes, angle changes of the corner. And then we just pick the two edges that defines the corner angle, and then it automatically places that. As you see, we are adding it here. It actually adds that mullion and responds to the geometry really beautifully. So that shows our mullion application. Here, I'm going to try to explain the automation. This is a little complicated in the sense that actually it has been a while since we did this project, so hopefully I will remember enough to explain it correctly. But basically, I mentioned that we organized and list the panel surfaces as per left, typical, right. Those are the most occurring panel types. And then we divide them a second level of glazing and spandrel because they have different panels, basically. And then here we are using the ECAL script to apply types and adjust. I think there's an error coming, but not from somewhere. Is this cool? No, that's a mistake. And it helps us with automation. What it helps us is to choose the right type of parts in the right surfaces. So here what we are showcasing is these are some of the type of panels that we have identified through automation. What it does is it marks its corner conditions and counts how many corners there are. And it counts how many corners on one edge. Actually, what it does is it extracts the boundary of the panel and explodes the boundary. I think this is a better example to show, or maybe let me show it here. Like it defines the fact that there is right edge. This is the right edge of this panel, and from extraction of this line of the panel and disassembling it, meaning that this is one line here, a second line here, instead of one continuous line. It knows that this is two separate parts. With that, it knows that these two parts are on the right side of the panel, and it instantiates the right panel mullion here. It knows that this is the bottom and the top and the left one. It also will know that on the left side, if there's another mullion or surface in an angle, it will know that it's not the left mullion, but rather corner mullion. So this is pretty smart and automation that we think can be further developed and used in multiple different applications as well. So just quickly going through the questions that we ask, it asks whether this bottom mullion exists. If no, then we eliminate that or replace a metal panel instead. If it is yes, we looked into the length of that. If the length is less than a certain amount, that's we turn that into a metal panel instead of glazing. And then that question of understanding the surface itself helps us define which mullion type or panel type should be applied there. That being said, I think I wrapped up our project here.